In this video for section 3.2, we're going to talk about end behavior of polynomial functions. Section 3.2 is all about graphing polynomial functions, and we've already talked about how to graph a quadratic function and how to graph a linear function. In this section, we're going to be graphing functions that have a degree of 3 or greater. And the first piece of that is determining the end behavior. End behavior tells us whether the arrows on the graph should point up or down. And the way that we determine that is by looking at the leading coefficient and the degree. And we defined leading coefficient and degree earlier, but if you don't remember, the degree is the largest exponent in the polynomial, and the leading coefficient is the number in front in the term that has the largest exponent. So for degree, we determine whether it's an even number or an odd number. For leading coefficient, we're going to use whether it is positive or negative. And there are 4 possible choices for what the graph could look like. And this is called the leading coefficient test. So if the degree is odd and the leading coefficient is positive, then the graph is going to rise to the right and fall to the left. Or it's going to have an upward pointing arrow on the right-hand side and a downward pointing arrow on the left-hand side. Now the part in the middle here where the dotted line is could look differently. However, the arrows are going to always be pointing in these 2 directions. If the leading coefficient is negative and the degree is odd, then those are going to switch. So it's going to rise on the left side and fall on the right side. So if the degree is odd, then the 2 sides always point in different directions. If the degree is even, then they always point in the same direction. So for an even degree and the leading coefficient positive, the graph is going to have both sides rising, or both arrows pointing upward. If the leading coefficient is negative and the degree is even, then both sides are going to be falling, or both arrows are going to be pointing downward. So example 1 says to use the leading coefficient test to determine the end behavior of the graph of f of x equals x to the third plus 3x squared minus x minus 3. Now the 3 terms here, they don't matter at all in terms of the end behavior. We only look at the term that has the highest exponent. And the highest exponent here is 3, so that means that my degree is 3. And 3 is an odd number. So that tells me that it's going to be one of these 2 shapes. Now let's look at the leading coefficient. Well, my degree of 3, my exponent of 3 is right here. The number in front there's nothing in front there, so that means it's an automatic 1. So my leading coefficient is positive 1, since there's no negative sign. So odd degree, leading coefficient positive, the graph is going to have this shape. It's going to rise to the right and fall to the left. So next you should look at checkpoint problem number 1. Do this in your notes, check your answer, and then you can do the homework for this section.